Okay, so we're going to look at a few examples where we're going to solve square root equations. So let's look at number one. So number one, we have the square root of 3x minus 2 plus 3 is equal to 7. All right, now um, to solve this square root equation, the goal is first of all to isolate the term that has a radical symbol. So we want to get the square root of 3x minus 2 by itself. So I'm adding this 3 here, this term 3, so I need to bring this 3 to the other side. So first thing I'm going to do is I'm going to subtract 3 from both sides. And so now when I combine like terms, this becomes 0, and so I get the square root of 3x minus 2 is equal to, and then 7 minus 3 is 4. Okay, now remember you got to solve this algebraically. So sometimes you can mentally solve this, but you got to do the work algebraically. Okay, so the idea is this. I'm trying to isolate the x. Right now I'm taking the square root of this expression. Well, one of the things you learned in your lessons was that one way to get rid of a radical symbol is to raise, and we'll go ahead and rewrite this, is to raise both sides of the equation to a power equal to the index. So you see I'm taking the square root, right? So the index is 2. So I'm going to square both sides. So that's the next step. So the first thing you had to do was to isolate the radical symbol. And then you're going to get rid of that radical symbol, you're going to raise both sides of the equation to a power that's equal to the index. So we are dealing with square roots here, so all of these you're going to square both sides. But if this was a cube root, you would raise both sides to the third power. If this was a fourth root, you'd raise both sides to the fourth power, and so on. Okay, now one of the things you got to remember is this. If you have, and I'm going to go ahead and write this information on another page, um, but if you have, and let's say we had this. So if you had this, the square root of 3 squared, right? And you all know that the square root of 3 squared means the square root of 3 times the square root of 3. And the square root of 3 times the square root of 3 is the square root of 9, which is 3, correct? And so if I had the square root of, let's say, 7 squared, then that will be the square root of 7 times the square root of 7, which is the square root of 49, which is 7. The point is this. Whenever you're squaring a square root, notice that the answer is just a radicand. The answer is just a radicand. And so the square and the square root undo each other. And so if you had the square root of, let's say, 17 squared, then the square and the square root are inverses of each other, so you're just left with the radicand. So you just say 17. And that takes us to this idea. So if I have the square root of x plus 2 squared, and if I simplify that, the square and the square root undo each other, so you're left with the radicand x plus 2. All right? So just remember there's some things that you've learned in the past that you can apply to many ideas in mathematics. So so using that idea, the square and the square root will undo each other. So I'm left with 3x minus 2 is equal to, and then 4 squared is 16. So notice I went from a square root equation to a linear equation. And we all know how easy it is to solve a linear equation. So I'm going to add 2 to both sides. So I get 3x equal 18. And then to get x by itself, I'm going to divide both sides by 3. So I get x to be 9. Now, one thing you got to remember, if you raise both sides of an equation, if you raise both sides of an equation, to an even power, or an even exponent, you must check for extraneous solutions. All right, so you must check for extraneous solutions. Okay? All right. So another word for extraneous is the idea that of false solutions. So you see this x equal 9, that is a solution to the linear equation. That's true because you can see that 3 times 9 is 27, and I'm sorry, 18 divided by 3 is not 9, I'm sorry. 18 divided by 3 is 6, excuse me. But you can check. So 3 times 2 is 6. I knew I did something wrong because the 9 wasn't working. So 3 times 6 is 18. 18 minus 2 is 16. So we know it's a solution here. But the question is, you have to check in the original because you could have introduced extraneous solutions. You could have introduced a false solution. So even though it's a solution to this linear equation, that linear equation is a different equation than a square root equation. So you have to check. All right, so if you raise both sides to an even power. If you raise both sides to an odd power, you don't have to check these, but to an even power you do. Okay? All right, so let's check. So we go back to the original problem. So you check in the original. So let's check x equals 6. So you go back to the original, the square root of 3x minus 2 plus 3, and you want to see if that's going to equal 7. So in place of x, I'm going to substitute 6. So I get the square root of 3 times 6 minus 2 plus 3. And you want to see if that's going to equal to the 7. Well, 6 times 3 is 18, right? So I get the square root of 18 minus 2 plus 3. 18 minus 2 is 16, so the square root of 16 plus 3. Square root of 16 is 4. 4 plus 3 does equal 7. All right, so that's your solution. All right, so it's not an extraneous solution. It's not a false solution. It's actually a solution. All right, so that's number 1. So let's look at number 2. So in number 2, we have this. So we have 2 times the square root of x minus 5 plus 3 is equal to 21. All right, so remember we discussed you want to isolate that radical symbol by itself, so that way you're going to, once you get it by itself, you're going to square both sides. Notice though, there are a couple of things that's happening here. So right, first thing, if you look at this, I'm multiplying the radical expression by 2, and then I'm adding 3 to whatever that is, and then that's equal to 21. So the first thing you're going to do is you're going to subtract 3 from both sides because you want to isolate this radical. So you want to, let me go ahead and rewrite this over. So basically you want to get this by itself. That's what you want. So you're going to subtract 3 from both sides. So I get 2 times the square root of x minus 5 is equal to, and then 21 minus 3 is 18. Okay. Then the easiest thing to do is next is to get this by itself, so we can divide both sides by 2 because right now you're multiplying by 2. Now someone may say, well, couldn't you just square right now? Yes, you could, but if you do, some of you are going to make a mistake. I'm going to tell you why. So the easiest thing to do is to divide both sides by 2. That is the easiest thing to do. And then notice what I have is 1 times the square root of x minus 5, which is the square root of x minus 5, is equal to, and 18 divided by 2 is 9. So now you have the radical by itself. So now we got to get rid of that square root symbol because I want to get x by itself. So we're going to raise both sides to a power equal to the index, and since we are dealing with square roots, it's always going to be squaring. So the square and the square root undo each other, and so I get x minus 5 is equal to 81. And then to get x by itself, we're going to add 5 to both sides, and so I get x to be 81 plus 5, which is 86. All right, and so I get x to be 86, but I got to check because remember I raised both sides to even power, so we must check for these extraneous solutions if they exist. All right, so let's check. So we go back to the original. So we're going to check x equal 86. So you go back to the original, which is the original equation. So remember when I went from a square root equation to a linear equation. So that 86 is a solution to the linear. That we know. But that linear is not the same kind of equation as the square root. All right, so since I square both sides, I could have introduced extraneous solutions. So just go back to the original, which is 2 times the square root of x minus 5 plus 3 equal 21. And wherever we see the variable x, I'm going to substitute 86. So I get 2 times the square root of 86 minus 5 plus 3. All right, and then I want to see if that's going to equal that 21. So that's what I'm interested in. Well, 86 minus 5 is 81, right? So I get 2 times the square root of 81 plus 3. Square root of 81 is 9. 2 times 9 plus 3. 2 times 9 is 18. 18 plus 3 is equal to 21. So this is your solution. So that's not an extraneous solution. That's not a false solution. That is your solution to this to this square root equation. Okay. All right. Now let me show you. Remember, there might have been one of you that might have said this. All right. So let me go ahead and look at number two again. So we have 2 times the square root of x minus 5 plus 3 equals 21. So remember, the first thing you're going to do is you're going to isolate this radical term right here. So you're going to subtract 3 from both sides. And so I get 2 times the square root of x minus 5 is equal to 18. Now, here's what some of you would have said. Some of you said, well, could I square both sides first? Now, at this point, could I square both sides? Yes, you can. All right, so watch. This is what's going to happen. It's going to be complicated, though. So watch. You square both sides, right? Just like that. But you got to be careful because you see this right here? That's no longer a simple idea. So if you look at this right here, that's 2 times the square root of x minus 5 times 2 times the square root of x minus 5. That's what that is, right? Well, 2 times 2 is 4, right? And so the square root of x minus 5 times the square root of x minus 5 I can write as square root of x minus 5 squared, and then we can use that idea that the square and the square root undo each other. So we have 4 times x minus 5. So that is what goes here. So you see how more complicated that is? So 4 times x minus 5. And you can even look at this and see it makes sense. 2 to the second power. So you have a product here. 2. So here's a factor and here's another factor. So each one of those being raised to the second power. 2 squared is 4. The square root of x minus 5 squared is x minus 5. But that is being multiplied by 4. And over here you get 18 squared, and when using your calculator, 18 times itself is 324. And now some of you may say, well, I'm going to go ahead and distribute, which is fine. You could have also divided by 4. So you get 4x minus 20 equals 324. And then adding 20 to both sides, I get 4x equal 344. Then dividing both sides by 4, knows what happens when you divide both sides by 4. 344 divided by 4 equals, and you get 86. All right. So just keep in mind that it was so much simpler, wasn't it, to have gotten the square root by itself? See how simple this looks compared to this? Some of you would have made a mistake in this little area right here. So try and see when you do some of these problems, look to see what's efficient, what's more efficient for you. All right, that was number 2. Now let's look at number 3. So here's another one. So now when we looked at these two problems, let me remind you, when we looked at these two problems, we went from a square root equation to a linear equation. See that? That was a linear equation. Went from a square root equation to a linear equation. All right, let's look at this one, number 3. In number 3, we have the square root of 5x minus 1 is equal, plus 3 rather, plus 3 is equal to x. All right, so again, I'm trying to isolate the radical. So I'm going to subtract 3 from both sides. So I get the square root of 5x minus 1 is equal to x minus 3. Now that's where I'm at. Okay, so just as we've done in the past, once I get the radical by itself, I'm going to raise both sides to the second power. Same thing here. Nothing is different. Just like we've been doing. Now you got to be careful though, because you do have a binomial here that you're squaring. All right, so let's talk about what we've said before. I am squaring a square root, so those undo each other. So I get 5x minus 1 equal, now be careful here, that's x minus 2 squared. So if you need to, you need to write that out. So that means x minus 2 times itself. So if I FOIL this, I get x squared. The outer is a negative 2x. The inner is a negative 2x. And then a negative 2 times a negative 2 is a positive 4. So I get x squared. These are like terms. So I get minus 4x plus 4. So that goes here. So now notice here I went from a square root equation to a linear equation. Here I went from a square root equation to a quadratic equation. So this is quadratic now. Okay? So that's quadratic. And in our case, these quadratic equations are going to be factorable. So you're not going to have to use the quadratic formula for those. The ones I'll give you be factorable. Okay, so let's go ahead and notice. Remember, when you're solving a quadratic equation, you want to get 0 on one side. So we want to put this in standard form. So I'm going to go ahead and subtract 5x from both sides. Notice I'm aligning my like terms. Then when I combine like terms, this is 0. 0 and a negative 1 is a negative 1 equal x squared. A negative 4x and a negative 5x is a negative 9x, and then plus 4. Adding 1 to both sides this time, and notice I'm aligning my constants. Negative 1 plus 1 is 0. You needed a 0 here, equal x squared minus 9x plus 5. Okay, now let's see. I think I made a mistake here because that's not going to be factorable. So let me see what I did wrong. Oh, it's right here, right here. So you see where I had the x minus 3? I put x minus 2. So let me go ahead and fix this. Let's fix this. So this is x minus 3. So we got to fix this. So that's negative 3x and a negative 3x, and that's going to be x squared minus 6x, and then plus, and then negative 3 times negative 3 is a positive 9. So plus 9. So I made a mistake there. So let me just go ahead and redo this. So this is going to be number 3. It's getting a little messy. So you got to be careful when you rewrite things, because you could as you're talking about it, you could easily mess up. So let me go ahead back and fix this. So this is number 3. We have the square root of 5x minus 1 plus 3 equal x. So just like we mentioned, you want to get x, the radical by itself, so you're going to subtract 3 from both sides. So you get the square root of 5x minus 1 equal x minus 3. Then you square both sides, right? And so the square and the square root undo each other, so you get 5x minus 1 equal x minus 3 squared. Now remember, when we squared that x minus 3, we ended up with this trinomial. So that's going to be 5x minus 1 equal x squared minus 6x plus 9. Okay? All right, now it should work this time. So I'm going to subtract 5x from both sides. 5x minus 5x is 0. 0 to negative 1 is a negative 1 equal x squared. A negative 6x and a negative 5x is a negative 11x, and then plus 9. Adding 1 to both sides, I get negative 1 plus 1 is 0. That's what you needed. Equals x squared minus 11x plus 10. Okay? Now, let's go ahead and factor this. Now, remember, when you have an equation, you can transpose the sides. So let's go ahead and rewrite this so that way I have x squared minus 11x plus 10 equal 0. Okay, I'm going to go ahead and factor now. So I get x minus 10, x minus 1 equals 0. All right, so that's going to give us this. And then I'm going to use the zero factor property. So I get x minus 10 equals 0, x minus 1 equals 0. So I get x to be 10 and x to be 1. Okay, now notice when we did the previous problems, since I raised both sides to even power, you must check for extraneous solutions. In these, I only had to check one because there's only one proposed solution I ended up with. But here there are two, so you got to do both. So we got to check. We have to check. So let's check x equal 10 first. So we go back to the original. Here is the original. So I get the square root of 5x minus 1 plus 3 equal x. So in place of x, I'm going to substitute 10. So I get the square root of 5 times 10 minus 1 plus 3. And I want to see if that's going to equal x, which we're saying is 10. Well, 5 minus 10 is 50, right? And then 50 minus 1 is 49. So that becomes the square root of 49 plus 3. Well, the square root of 49 is 7, and 7 plus 3 is equal to 10. So 10, this proposed solution, so remember I'm using the word proposed, so these proposed solutions, because the 10 and 1 are solutions to this quadratic. But since I raised both sides to even power, they may or may not be solution to this square root equation. So you have to check. All right, so that's a solution. So I'm circling it. Now let's check x equal 1. So check x equal 1. So again, go back to the original problem. So that's the square root of 5x minus 1 plus 3 equal x. So in place of x, I'm going to substitute 1. So I get the square root of 5 times 1 minus 1 plus 3. And I want to see that's going to equal x, which we're saying is 1. 5 times 1 is 5. 5 minus 1 is 4. Okay? So that's the square root of 4. Now, is the square root of 4 plus 3 equal to 1? That's the question. Well, the square root of 4 is 2. And 2 plus 3 is equal to 5, which is not this 1 is supposed to equal. So that means that x equal 1, this is your extraneous solution. That's an extraneous solution. So the only solution then, you're going to say the only solution is x equal 10. All right. Now, notice that in this particular case, I went from a square root equation to a quadratic. And in this particular quadratic equation, there were two solutions to this quadratic. So when you do these, when you check them, it could be that both work. It could be that one works, the other one doesn't, just like in this case. Or it could be that neither work. All right. So just keep in mind the different scenarios that could occur. All right. But you must say that that if this is extraneous, let me know that this is extraneous, so I can see that you checked, and that the only solution, you must say what the solution is to this. The only solution to this square root is x equal 10. All right. So that was number 3. Okay, let's look at number 4. In number 4, we have this. So it's not a difficult process. It's very, very simple to do. So number 4, we have the square root of 4 minus 2t minus t squared equal t plus 2. All right, so notice that in this case, the radical expression is already by itself. So all I need to do is raise both sides to the second power, since I'm dealing with the square root. So let me go ahead and rewrite this over, just like this. And notice what happens. Oops. Okay, notice what happens. We go ahead and square both sides. And so when I square both sides, the square and the square root undo each other. So I get 4 minus 2t minus t squared equal, now let's talk about this right here, t plus 2 times itself, right? So let's FOIL this out. T times t is t squared. The outer is 2t. The inner is 2t. And the last, 2 times 2 is 4. Combining like terms, I get t squared plus 4t plus 4. 2t plus 2t is 4t. So that goes here. So that is this trinomial, t squared plus 4t plus 4. Okay. Now, notice that I went from this square root equation to this quadratic. So I'm going to go ahead and rather than, you see how if I bring this t squared over, I'm going to get a negative t squared. Sometimes it's easier to deal with if the coefficient of t squared is positive. So I'm going to go ahead and bring everything to the right hand side. So let me go ahead and I'm going to do one thing at a time. So I'm going to add t squared to both sides, just like this. And so I get 4 minus 2t, this is 0, equals t squared plus t squared is 2t squared plus 4t plus 4. Then I'm going to go ahead and add 2t to both sides. And so the negative 2t and the 2t is 0. So that's 0 here. So I get 4 equal 2t squared plus 6t plus 4, right? Then I'm going to subtract 4 from both sides. So notice I'm aligning my like terms. 4 minus 4 is 0. You need a 0 on this side, equal 2t squared plus 6t. Okay, now let's go ahead and factor this. Now notice that the constant, there's no constant term there, so the GCF here is 2t. So I'm going to go ahead and factor out a 2t. And I'm going to go ahead first of all and transpose those two sides. So I get 2t squared plus 6t equals 0. So I'm going to go ahead and factor out a 2t. So I get 2t times t plus 3 is equal to 0, right? And just remember that since this is an equation, you see this number right here, this coefficient, you could divide both sides by 2. So watch, you could do this. And so because it's an equation, what you do to one side, you do to the other. So, but you cannot divide by a variable. You can only divide by a constant. So notice that the 2's divide out, and 0 divided by 2 is 0. So I get t times t plus 3 is equal to 0. And then when you solve this equation, you set each factor equal to 0, you get t equals 0, t plus 3 equals 0, t equals 0, and then t equal negative 3. So those are your two proposed solutions. You would get the same thing even if you did not divide both sides by 2. So what some students like to do is see the monomial factors here, the 2 and the t, they tend to leave the 2t together. So in their mind, they're saying 2t times t plus 3 equals 0. So using a zero factor property, 2t must equal 0, and then t plus 3 must equal 0. So if you have a product, if one or more factors whose product is 0, then one of these factors has to be 0. Then dividing both sides by 2, hence that's what we did here, wasn't it? So you can either do it here or you can do it here. I get t to be 0, which is what we got here. And over here, you get t to be negative 3. So those are your proposed solutions. But I raised both sides to the even power, so you got to check for extraneous solutions. So let's check. So let's check x equals 0, I'm sorry, t equals 0 first. Let's go back to the original, and remember the original was this, the square root of 4 minus 2t minus t squared equal t plus 2. So in place of t, I'm going to substitute 0. So I get the square root of 4 minus 2 times 0 minus 0 squared equal 0 plus 2. So in place of t, wherever I saw the variable t, I substitute 0. Now notice that all this right here is 0 except for this 4. So I get the square root of 4. And then over here, this is just 2. So the question is the square root of 4 equal to 2? The answer is yes. 2 does equal 2. So t equals 0 is a solution. Now let's check t equal negative 3. So let's check t equal negative 3. Again, go back in the original problem, which was 4 minus 2t minus t squared equal t plus 2. All right, so wherever you see the variable t, I'm going to substitute negative 3. So I get the square root of 4 minus 2 times negative 3. Be careful with the negatives. You're going to need parentheses. Minus, in parentheses, negative 3 squared. So be careful with the negatives when the variables, when you're substituting negative. And then that's going to, you want to see if that's going to equal negative 3 plus 2. All right, so let's look at this right here, this radicand. Square root of 4. A negative 2 times a negative 3 is a positive 6. Now remember, you got to square this negative 3 first. Negative 3 squared is 9, so now you're subtracting 9, right? Okay, now look at this. 4 plus 6 is 10. 10 minus 9 is 1, so this is square root of 1. But the square root of 1 is 1, right? Okay, so that side's 1. Over here, what's a negative 3 plus 2? Well, that's a negative 1. Those are not equal. So negative 3 is an extraneous solution. Negative 3 is an extraneous solution. So the only solution is 0. So the only one that works is going to be 0. So the solution to this square root equation, the only solution is t equal 0. So make sure you understand that in the blank, you're just going to put t equals 0 is the only solution. Okay? All right, so that's number 4. Let's look at one more. So this is number 5. So in number 5, we have the square root of 5x plus 4 equal 3 square root of x. Now, don't let the fact that you have radicals on both sides throw you off. This is a simple one because on the right side, you have just one term, and that's a radical expression. On the other side, you have one term, and that's a radical expression as well. And they're both square roots. So right away, I'm going to go ahead and square both sides, right? So that will be your first inclination. Square both sides, right? No big deal. You're going to do something like this. All right? This side's easy because from our previous explanations, our discussions, you know that the square and the square root will undo each other. So you get 5x plus 4. Now be careful over here. So watch. 3 times the square root of x squared, right? So that's very similar. And let me go quickly find it. That is very similar to something we had earlier, and that was this. You remember this, where you had 2 and you were 2 square root of x minus 5 and you're squaring it? So remember this right here? That's that same idea. So 3 square root of x squared means 3 square root of x times 3 square root of x, right? And then 3 times 3 is 9, and the square root of x and the square root of x is just x. So that's just 9x, isn't it? So 5x plus 4 equals 9x. 3 squared 9, the square root of x squared is x, right? So remember, another way you can think about this is where you had this, so each factor is being squared. So you can say 3 squared, and then you can say square root of x squared, right? And then 3 squared is 9, and over here, the square and the square root don't do each other, so you're left with x. So multiple ways to think about this. But now notice that I ended up with a linear equation. So I'm going to go ahead and subtract 5x on both sides. And when I do that, this is 0. When I combine like terms, I get 4 equals 4x. Divide both sides by 4. I get x to be 1. So my proposed solution is 1. Now I know that 1 is a solution to this linear because 5 times 1 is 5. 5 plus 4 is 9. And 9 times 1 is 9. So 9 equals 9. But is it a solution to the original? You have to check. So let's check the original. So let's check x equal 1 into the original. And the original, always go back to the original. You must go back to the original. So wherever we see the variable x, I'm going to substitute 1. So I get the square root of 5 times 1 plus 4. And I want to see if that's going to equal 3 times the square root of 1. Well, 5 times 1 is 5. 5 plus 4 is 9, isn't it? So I get the square root of 9. Over here, the square root of 1 is 3. The square root of 1 is 1. So I get 3 times 1, which is 3, and the square root of 9 is 3, so those are equal. So x equal 1 is your solution. So the solution is, and there's only one here, x equal 1. Okay? So that was the idea behind solving square root equations. Now these are the basic types. Now notice that when we did this, we raised both sides to the even power 1. So there are situations where you may have to raise both sides to the second power twice, but that's not in this part here. That's a different lesson. Okay, so that is the end of this lesson.